Bonjour à tous et à tous. Je m'appelle Cormac. Je viens d'Irlande. C'est la raison j'ai cet accent qui est très drôle. Okay, malheureusement, je ne suis pas, comment on dit, courant en français. Donc, nous devrons parler en anglais pour cette présentation. Merci. Phew. That was the toughest part of the presentation. Merci. Okay, so I've been with VMware quite a while, usually working on storage stuff. In the last 4 or 5 years, it's been predominantly what we call hyper-converged infrastructure, HCI, and of course VMware's HCI offering is vSAN. So I'm going to talk a little bit at the beginning about what we've done in the most recent release of vSphere 6.7 Update 3 for vSAN. But predominantly what I would like to talk about is what we're doing in the area of cloud native storage, in particular Kubernetes, and what we're doing there. So this is what I plan to talk to you about. If I get out of the way, maybe I'll stand over here. So we'll talk about what we've done in 6.7 U3, and then we'll talk about Kubernetes, in particular the block storage, Kubernetes block storage on top of vSAN. Can I ask, how many vSAN users or customers do we have in the audience? Okay, quite a few. How many of you have Kubernetes in your environment? How many of you are thinking about Kubernetes? How many people have no idea what Kubernetes is but would like to know more? Great. So this is where I was about a year ago, believe me. So I'll take it very gently through that. So for those of you who are using vSAN or considering using vSAN, please check out storagehub.vmware.com. It's where we put all of our documentation about vSAN, reference architectures, use cases, everything you want to know about vSAN, you'll find on that site. I put that at the beginning of every presentation because you'll find a lot of good stuff up there. For those of you who are not aware of what vSAN is, very simply what we do is we take a bunch of ESXi hosts, we put them into a cluster, we take all the local devices of those ESXi hosts, we add them all together, and we get one distributed data store called the vSAN data store. And from there, we can start provisioning virtual machines onto that data store. Now, we do something quite interesting in the way we provision onto the vSAN data store through a utility or a feature called Storage Policy-Based Management, SPBM. So this means that we can deploy virtual machines that have RAID 1 mirroring, or RAID 5 or RAID 6, erasure coding, parity, whatever you want to call it. So we have lots of different ways to do things like that. What's nice about it is you can start very small and then you can add more and more hosts to the cluster and scale it out and go up to the maximum number of hosts that we support in a vSphere cluster, 64. So you can imagine with 64 ESXi hosts and all of that local storage, you get some very large vSAN data stores out there. So that's vSAN in a nutshell, and it is the building block for our VCF or VMware Cloud Foundation feature set as well. So it's been very popular, to be honest. It is the fastest growing product we've had since ESX, and now we're at about 20,000 customers or so. Get lots of awards and stuff as well. I just thought I'd put this up just to show you the sort of how much it's been used, what it's been used for, things like that. Now this is our dial home data. You know when you enable CEIP, which I can never remember what it stands for, customer experience something. Yeah, merci beaucoup. So 17% of our vSAN customers actually have that enabled, and this is the sort of information that we're getting back. However, I will point out that some of our largest customers are not included here. Our largest customer has 100 petabytes of vSAN storage. Our second largest has 80 petabytes. So you can see it's been pretty well adopted, not just for the small remote office, branch office, SMB type solutions, but also for the large scale enterprises as well. Very good. So 67U3, I've broken it out into 3 different sections. The first of these is what we did to improve performance in that release. The next one is what I call intelligent operations. I prefer to call it guardrails. It's essentially to stop you doing stupid things with vSAN. Okay. The last one then is the kind of Kubernetes area, where we're showing you how you can use vSAN to be the underlying storage infrastructure, not just for virtual machine workloads, but also for container workloads. So those are the 3 areas that we will cover. Enhanced performance first. So this is, if you're really interested in what we've done in performance, my colleague Paddy O'Riordan, who's also from Ireland, he delivered a session, or is delivering a session as well in Barcelona. This is the one in the US. I guess it'll be 1757 BE in Europe or something. But this is available online already. So if you want to find out really what's happening in 67U3 performance, check that session out. I've taken a few of his results, for want of a better description. So Paddy did all these tests in the lab. This is his test rig that he used. You can see it's pretty beefy. You know, it's got Intel Optanes. It's also got NVMEs there as well. The crux of this is deduplication and compression, because this is where we've made the major enhancements. That was always, let's say there was always some challenges with dedupe and compression reaching the performance thresholds that we could reach without having it enabled, and this is where we spent a lot of time improving that. This was his original test plan. So first off, we're just going to look at the random test plan, or random IO pattern that he ran, 70-30, you can see here. I guess these slides will be available later if you want to look at it in more detail. So what we've seen between the 67U2, which is just the previous release, and the U3 is some significant performance improvements with dedupe and compression enabled now, remember. And so we've seen improvements of 15% in the IOPS and throughput, but also a latency reduction of up to 20%. All right. What was probably more interesting is what we call this jitter effect. So what this is the standard deviation. So what we've done is we've taken the average of the latency over a period of time as we increased the number of outstanding IO. And what we've seen before is that there was a lot of jitter, so the latency was kind of all over the place. What we see now with the 67U3 release is we've got a pretty standard latency return coming back. So pretty big performance improvements there. Now this is for the random I/O. Paddy also put it through its paces for sequential I/O. So you can see the test plan here now for sequential, and this is where the major enhancements have come through. And you can see IOPS and actually also the throughput, they've increased by about 44%. Now the key thing here to keep in mind, it's the deduplication and compression has been enabled. If you're not using dedupe and compression, you won't see these significant improvements, but if you are using it, we've had some pretty remarkable results come from the 67U3 release. And then just to close off, the latency with the 67U3 release with the sequential workload has dropped by up to 33% in this particular case. So yeah, if you are a vSAN customer, you're using dedupe and compression, it is worth your while considering a move to the 67U3 because you will see some significant performance gains. Okay. Any questions before I leave? That great. Okay. So improving simplicity and consistency of operations. Let me just fill that out there. Get rid of the mouse. So there's a whole bunch of things that we've did. As I said, these are more around guardrails. Things like, well, let's take this one for instance, the maintenance mode. If I had a 3-node vSAN cluster, and a 3-node vSAN cluster, let's say I deployed a virtual machine that had a RAID 1 configuration. So a RAID 1 VM would have a copy of the data on the first node, copy of the data on the second node, and maybe this witness quorum on the third node. So I want to put one of these hosts into maintenance mode to do some, I don't know, some work, maybe upgrade some firmware or something like that. So it lets me put the host into maintenance mode. My virtual machine is still accessible because I still have a quota majority, or I have a vote majority. In other words, 2 out of the 3 components are available. If I went along and wanted to put the next host into maintenance mode, which would mean that my virtual machines would no longer be available, do you think, we should say something like, stop, maybe you don't want to do this because all your virtual machines will be impacted? Well, in the past we didn't, but that's what these enhancements are about, or that particular enhancement is about. Better resync behavior, well, not really too much to say about that. It's just really not to keep building components that are missing when we start hitting capacity thresholds. Component rebalancing. This one is just, any one of you with vSAN use iSCSI with your vSAN? Okay. So in the past, or prior to the Update 3 release, what we would have to do is take the iSCSI device offline in order to resize it. Now you can do that online. This one is quite interesting. Does anyone run Windows Server failover clusters on vSAN or Microsoft failover clusters? Okay, yeah. So with Microsoft failover clusters, what you do is you have a shared device which needs to accept what's called a SCSI tree reservation when one node or the other node wishes to take over the service. We could not do that on vSAN. Before, we would have to have an external shared device, typically maybe the iSCSI device that we talked about there. But we would have to have something external to vSAN in order to put this SCSI reservation on. 67U3 means we can do that natively now on vSAN, meaning you could now run Windows Server failover clusters on top of vSAN without the need for any external device. And some other things here as well, just what's going on when there's a resync operation, increasing the parallelism. And I'll show you something about the simplified capacity usage later when we look at containers and virtual machines running on the same vSAN. Any questions about that?
About the automated intelligent component rebalancing, what is new in regard to what was previously? It started by itself or it's an auto-return?
Correct. So the question is, what's the automated intelligent component rebalancing? And this is where all of the virtual machines that you deploy on top of vSAN, they're all individual components. And so sometimes you could end up with some hosts in the cluster having more components than others. This is simply about getting that rebalanced automatically. So it's available now without you having to do any manual intervention. Okay. So the last topic is 67U3. It's cloud native storage and Kubernetes persistent volumes on vSAN. However, I thought it'd probably be worthwhile just kind of covering a little bit about Kubernetes before we start delving into this, because otherwise it probably won't make too much sense. So let's go through some basic Kubernetes storage constructs and look at how they map to storage constructs on vSphere. Firstly, what is Kubernetes? Well, Kubernetes seems to have won the battle of being this orchestrator for containers. So it now has become, I mean, there are other ones out there, Docker Swarm or Mesos and so on, but Kubernetes seems to be the one that has gained most mindshare. So it's all about being able to deploy container-based applications, manage container-based applications, and scale up and down container-based applications. I will point you to another new website. This is something that's been kicked off by our Cloud Native Applications business unit. If you're interested in learning a bit more about Kubernetes and just seeing some starter videos, tutorials, things like that, Kubernetes.academy has just recently started off. You may have heard of somebody like Scott Lowe. We come across Scott's name. He's quite big in the VMware community. He's sort of driving this among others. So it's worth checking that out. So what is Kubernetes? Let's talk about a Kubernetes cluster, and let's talk about it in terms of, if you deploy Kubernetes on vSphere, what does that mean? So we'll start off, and first of all, there's what's known as the control plane. We used to call this the master in the past, but now it seems to have a new term called the control plane. So you have a control plane, and you have these workers. So typically, the control plane is going to manage everything for you. The workers are where you're going to deploy your applications. From a vSphere perspective, there'll be one or more virtual machines responsible for the control plane, and then one or more virtual machines which will be workers. In the control plane, you have this thing called an etcd. It's really just a key value store, but for all intents and purposes, you can think of it as the Kubernetes database that's keeping track of all the components that are within the database. That's basically what it is. You then have this API interface, and this is how we interact with Kubernetes. You may have come across a command called kubectl or kubekettle. This is the command that allows you to deploy, to create, to delete, and so on. But all of those activities go through the API server. So let's say there's a request to roll out an application. Let's say our application is, multiple copies of Cassandra or Couchbase or something like that. I noticed the Couchbase guys were here. So what you then have is a component called a scheduler, and the scheduler is responsible for picking out which of the workers we should be putting the different components onto. Okay, and then the workers themselves, obviously the one thing they run is what's known as the container runtime, or CRI, container runtime, the most popular of which is Docker, for obvious reasons. Again, there's lots of other ones out there, but Docker seems to be the primary container runtime. The other thing we have in these, again, virtual machines for us, but workers, is this thing called a kubelet. And this is the agent, and this is how it communicates to the control plane. All right? So the scheduler might say, oh, I need this worker to run these pods for me or whatever. Get onto pods next. And it's the kubelet that it talks to. So you will have this component in each of the virtual machines that is listening for instructions and actually sending back health information and so on. Last but not least, we have our pods, and these are our applications. So again, if I decided I wanted to roll out a Cassandra database, or as I said, a Couchbase database, and initially I might want to start with 3 components in that deployment, I would end up with 3 pods deployed across the different workers here. And that is Kubernetes, very simplified in a nutshell. Okay, does it sort of make sense a little bit? Yeah? Okay, so let's move on then. And the bit that we're actually most interested in is the infrastructure part. Okay, so we will, as VMware, we're able to provide all that compute, all the memory, all the storage, all the networking infrastructure in order to run these Kubernetes clusters. And the great thing about vSphere is because all these Kubernetes clusters are within virtual machines, we could run a lot of clusters at the same time on top of vSphere infrastructure. But the bit I want to talk to you about today is the storage bit. So let's talk about the storage bit. Now, storage in I suppose the primary storage component within Kubernetes is this thing called a persistent volume. Okay, so a persistent volume, we can think of that as a VMDK, a virtual machine disk. Now, in the past, you had to have these VMDKs created statically. So for us, it was VMKFS tools, and we build out a VMDK, and then we get the path to that VMDK, and then we'd be able to use it within Kubernetes. But that wasn't really scalable. So what Kubernetes created was this thing called a PVC, persistent volume claim. Persistent volume claim, integral part of Kubernetes storage, but it's basically just a request to dynamically create a persistent volume. So that's all the PVC is, a way of creating a PV dynamically on the fly, so to speak. Now, what you'll find with Kubernetes is YAML is king. Everything is done through YAML, which is short for yet another markup language. So what you'll see here is a YAML manifest file for building a persistent volume. It's actually a persistent volume claim, but when we run it, it will build a persistent volume. Now, what sort of persistent volume should I be creating? So we have created a driver, so this is VMware have created a driver for Kubernetes, which allows us to do things like a storage class. So the storage class is what it says, a class of storage. And if you remember, I spoke to you, probably the very first thing I was telling you about vSAN is that we can instantiate on top of vSAN using a storage policy. Well, in Kubernetes, in these persistent volume claims, we can do the same thing. We can say, I would like a persistent volume to be created with maybe a RAID 1 or a RAID 5 or a RAID 6 or a stripe width or all of those things that we support in vSAN through this storage class. So this is a way of creating a persistent volume. It's going to create a persistent volume which is available only to this container. It'll be 20 gigs in size, but it's going to be created using this policy. Let's have a look at that policy. And so that policy might look something like, I don't know, gold on the vSAN data store. And of course, back in vSphere, you will have this gold policy already created. Now, this is a reference to our driver. This is the older driver. We've just created a new one. I'll get into that in just a sec. But hopefully you can see the relationship between a PV, a PVC, and a storage class now. If you understand that, you pretty much have a good grasp of Kubernetes storage already. All right? There are a few other things as well which are quite interesting. I talked about Couchbase and Cassandra and being able to scale out these applications, maybe scale them back in again. Typically with those applications which require persistent storage, when you scale these applications out, you want the compute part, which is the pod, to scale out with the storage part, which is the PV at the same time. How that is achieved in Kubernetes is through the concept of a stateful set. So with a stateful set, you can say, build me X number of replicas, and for each replica you will have one pod and one persistent volume. Well, you will also have a PVC as well, but this is what one of those looks like. Again, it's like YAML, but you can see that you have a specification that says with these volumes, this is where I should mount them. So within the application itself, it could be, well, in this case it is Couchbase, funnily enough. And then you have the specification that just looks like the PVC down here, which is read write once again, and what size is it, and so on. And then the storage class specified. So if you have something like that, obviously it's quite simplified. You will be able to create a single instance, 2 instances, 10 instances, just from the kubectl command line. All right? There's only one other thing I wanted to talk to you about, and this is read write many volumes. Now I've been showing you read write once volumes. There's once. Forget myself. Yes. Read write once, which means only a single container can access this volume. What if I wanted multiple containers to access the same volume? Then it becomes read write many. And typically read write many volumes in the Kubernetes space are NFS. So you might have a YAML manifest file that sort of looks something like this. The NFS server could actually be a pod itself, or it could be an external NAS array. Doesn't really matter, you just fill in this portion here. But now what you'll find is that multiple pods will be able to access that particular persistent volume type because it's read write many. Make sense? That is essentially all you need to know. Well, it's all I know, and I seem to be able to get on okay with it. So, but that doesn't say much, I guess. Great. Okay. So what have we done? So that's the Kubernetes side of things. What have we done at VMware to kind of make our lives easier to work with Kubernetes? Let's have a look. So I'm going to talk to you about CSI, which is the new driver that we've developed, and CNS, which is a feature of 6.7U3, where we get full visibility into how Kubernetes is consuming vSphere storage. So you might ask yourself, well, I've heard somebody say that containers is for stateless. In other words, I spin up a container and I do some work and then I throw it away again because I don't really care about the results. But this is a survey from a company called Datadog, who do a lot of monitoring of Docker and containerized applications. And what they've found out, well, this is probably about a year old, is that 7 of the top 10 Dockerized applications require some sort of persistent storage. So stateless is a bit of a myth. There is still definitely stateless containers out there. Web servers for one, load balancers, ingresses, those kind of things, where they're just passing through. But there is definitely a requirement for a lot of stateful applications as well. So how do you do that? I mean, yes, you could, use some cloud-based storage if you so wish, but a lot of customers want to be able to run this in their own data centers on premises as well. And so that's why we decided we would work on something that would help address that. So we started off with Project Hatchway. This is a little bit of a history lesson, I guess. We started off with Project Hatchway, and in Project Hatchway there were two different components that we developed. One was for Docker, to be able to create persistent volumes for Docker itself. The other was for Kubernetes, to create persistent volumes for Kubernetes. And so both of them were just about instantiating virtual machine disk files on vSphere storage so that they could be consumed by containers, whether they were in Docker or whether they were orchestrated by Kubernetes. But what started happening then is that everybody was building these drivers and they were going into the core Kubernetes code. So the core Kubernetes code started to really bloat and get large, and it became very unsustainable. So this initiative called the CSI, the Container Storage Interface Initiative, that was all about getting everybody to take their driver code out of Kubernetes core and create plugins. So it's very beneficial because it means that we don't have to wait for the next release of Kubernetes in order to bring in changes to our driver. We can release the driver, on a SKU with the Kubernetes releases, which wasn't something we were able to do before. So this is where CSI has come from. We have a vSphere CSI driver, which comes as a plugin that when you now deploy Kubernetes, you have to install yourself. And if you're interested, there's tutorials and everything on how to do that at the bottom here. But these slides will be available to you, as I said. So what then is CNS? So CNS is using that CSI driver that we've created. And what we're able to do is we're able to manage and monitor all of the different objects that we're building on vSphere storage and bubble those up into the vSphere client to show you who's using what. So you could have multiple Kubernetes clusters running on your vSphere infrastructure, multiple different applications building all sorts of persistent volumes. This is a way to track that. All right? So this is the components. As I said, it's in 6.7U3. The interesting thing, I guess, is first-class disks. I don't know if any of you have come across that. The way to think of first-class disks, if you think today or prior to U3, how would I take a snapshot of one disk? You basically have to snapshot the whole virtual machine, right? So operations like snapshot are virtual machine centric. What first-class disks allow us to do is do operations on a per-disk basis. In particular, things like snapshots. But this could change to things like maybe we'll do storage vMotion at some point in the future to be able to move individual VMDKs and things like that. So it's essentially making the VMDK a first-class citizen in vSphere, if that makes sense. So that's what AFCD is. We do have the CNS control plane. So this is just passing data from the Kubernetes nodes. So we're able to track who's doing what, which policies they're using, are the policies compliant as well, and all of that good stuff. So I have, so this is the sort of scenario that we're trying to address. If we take, I just took vSAN, but it could be any sort of vSphere infrastructure using any sort of vSphere storage as well. And then somebody comes to you and says, we want to deploy a new modern application onto our infrastructure, okay? And we want that modern application to be orchestrated by Kubernetes. And you'll go, well, yeah, I heard Cormac talking about it at the VMUG. Can't be that hard. It's just a few VMs, right? So I'll roll out a master VM and I'll roll out a bunch of worker VMs and I'll pass it off to my DevOps team and job is done. Yeah, very easy. So their DevOps team takes the Kubernetes, they build their new modern application, which could be very many pods. Of course, it could also be some virtual machines as well. And then they do a whole bunch of persistent volumes here as well. And it goes live and everybody is really happy. And then about 2 days later, you get a phone call from the DevOps team. The app is running slow. Users are complaining. It must be infrastructure. Has to be the infrastructure, right? But now you can go, aha, at least I can check that. So how do we check it? We have this view now built into the vSphere client where we're able to see all the information about the individual persistent volumes. We can see what cluster, what Kubernetes cluster they're running on. We can see which labels they're attached to. So we can very quickly narrow down and have a good one-to-one conversation between the DevOps team and the VI admin team about, well, what part of the application is slow? Where is that storage based? Does it make sense to maybe change the policy associated with it? All of those kind of things. So this is one search view here. You can see that it's using that policy. It's on a vSAN data store. The really nice thing then is that we can select, if I just show you back here, I could click on any of those volume names. It would take me, if I was using vSAN, to where that volume exists. In other words, I can see that it's on a particular Kubernetes worker. And then from there, I could actually go and look at the layout. And so this might be a RAID 1 in this particular case. So you can see all of that details through the UI now. So go all the way from the persistent volume in Kubernetes down to how the components are laid out on the vSAN data store. It's pretty neat, pretty neat. Okay, so the other thing, and I touched on this earlier on as well, is how we now have some more improved visibility into, again, this is for vSAN, how vSAN is being consumed. So this is a new vSAN capacity view in 6.7U3. The nice thing about it is that I think that it should scale out itself. So you can see as the space is growing and what's happening here, the color changing. But what I particularly like now is you can actually see block container volumes. So persistent volumes, how much are the Kubernetes applications consuming of my vSAN data store? So you get that breakdown as well. The other nice thing is you'll see persistent volumes that are attached to worker nodes. In other words, they're in use by applications, and persistent volumes that are just left hanging around, not attached to anything. So that's a nice feature of it as well. Cool. Demo time. Right. So here is my vSphere infrastructure with my vSAN, and it's running a Kubernetes master and 5 Kubernetes workers. Okay, so from here I can actually go and show you what we were looking at earlier, where I can get down into the capacity view, I think it is. Yeah. And so within that capacity view here as well, you can see there's a lot of really good stuff added to vSAN, but let's keep going and just focus on the Kubernetes side of things. And so we saw here as well, I think, that there was a breakdown, and you can see block container volumes that are attached to VM. So there's quite a bit going on here. There's a lot of, looks like there's a lot of persistent volumes deployed. So I can now go to that CNS view that we saw earlier with the container volumes view. And yeah, there's all sorts of applications running here. You can see all the PVCs. This is really useful because Kubernetes uses labels everywhere. And so it's how it tracks, applications, whether they're production, whether they're pre-production, test, dev, whatever the case may be, they're used all over the place. So what we're doing is we're pulling all of that information back to display it here as well. You can see the data store, you can see the policy is compliant, and there's the volume ID, which you'll be able to match back to Kubernetes as well if you so wish. So what we can do here is we can actually get in, well, yeah, just to show you, there can be multiple labels associated with different volumes as well. So now what I want to do is I just want to go and look for maybe the Cassandra database application. So I can click that there, and immediately we're filtered out, and so we only have a view of Cassandra now at that point. So there we go. It looks pretty good. Now, what I want to do at this point, I think, is I want to go to this now is the Kubernetes dashboard. There's, I suppose it's one way of getting visibility into what your Kubernetes cluster is using, but I don't know if it's used that much, but it's certainly, for the purposes of this demonstration anyway, it'll give you a good overview. Now, we want to look at Cassandra. Kubernetes has this concept of namespaces where you can actually isolate applications. So in this particular example, Cassandra is in its own namespace called Cassandra. It's only got a single pod or compute entity associated with it, and we already saw the persistent volume, so we can drop down and look at that persistent volume again. And so you can see that persistent volume, and that actually matches back to the persistent volume that we saw in CNS. So at this particular point, let's see what I can do here. Yeah, I think I can go back up. Oh, this Cassandra application is part of that stateful set concept. So at the moment, it's just one pod with one persistent volume. So what we're going to do is we're going to scale it out from one pod and one persistent volume up to 3 pods and 3 persistent volumes. So I can do that here. Let me just bump that up to 3. So let me just refresh it now, and hopefully we should be nearly at the 3. Yeah. So it's just waiting for the container. So the persistent volume, I think, is created. It's almost there. Let me refresh it once more. Excellent. So what we've done now is we've just scaled this Cassandra application from a single pod and a single persistent volume to 3 pods here, and presumably 3 persistent volumes. There we go. So let's pop back and let's have a look. And if I give this a refresh, so we've seen immediately that from vSphere, we can actually observe things happening back at the Kubernetes side of things. So we're able to see this relationship between Kubernetes persistent volumes and what's happening in vSphere from a virtual machine disk perspective. So cool. So let's look at this one in more detail. And so here you can see the persistent volume claim information. And actually just look at the basics. You can see even more information like which virtual machine it's attached to, which data store it's on, which policy, is it compliant, is everything okay with that particular object. So that's a pretty neat thing. And let's assume that perhaps the policy wasn't compliant or there was some accessibility issue. I can just click on the link here for the PVC. That takes me into the vSAN virtual objects view. Immediately it's got the persistent volume selected. You can see it's attached to that worker. More details there. And we can even go further and view the placement details. And you can see that that particular persistent volume, we can track it all the way back to a witness component here for vSAN, the first RAID 1 copy on an ESXi host, and even on the cache and capacity devices, and the second RAID 1 component there as well. So there you go. So it's pretty cool stuff to be able to do that, and hopefully it's going to address a lot of the potential issues that may arrive when you're running Kubernetes on top of vSphere, and there's a requirement to map what's happening at the Kubernetes space into what's happening in the underlying infrastructure, which in this case is vSphere. That make sense? What you think? Useful? Good? Yeah? Okay. So let's get back to the slides if I can. Now, one thing I talked about when I was talking about all the YAML stuff, most of it we've seen there. We've seen the persistent volume claim. We've seen the storage class. We've seen the stateful set. But the other thing that we looked at was the read-write many volumes, which I said was typically NFS. So this is a sort of tech preview that I'm giving you now. Yeah. So this is vSAN file services. So it's extending vSAN to not just do block storage, but also to do NFS initially, perhaps some others later on. So what that means is that if you're running Kubernetes on top of vSAN, not only will you be able to consume it for block storage, for read-write once, but you'll also be able to consume it for read-write many file storage, NFS. So we envision something like this. Should take the clicker back. Right now, this is vSAN that we already know about, virtual machines consuming block storage. What we expect going forward is perhaps not just file shares being consumed by virtual machines, but possibly file shares being consumed by containers as well. So this was announced at VMworld in the US. It is in beta, but it's a restricted beta. If you do have a real requirement or need to look at this and perhaps set it up and play with it, reach out to your local VMware representative. Initially, what we're thinking, or what we're aiming for, is just NFS version 4.1. Okay, but I would be at pains to point out that this is not going to be a replacement for your filers that you have. Certainly not in the initial release. What we're aiming for is very, I suppose, lightly used file shares, perhaps. It's a bit hard to define yet. We probably still have to quantify that for you. But I will point out that if we're not looking to go out there and kill all the FASs that are out there at the moment. So just want to point out that I think that's pretty much covers it. So I do have a question for you. So we're aiming to go with NFS version 4.1 initially. If you were a vSAN customer, and just you can pretend you're a vSAN customer for this question, which would you prefer to see next? So if you can just lift your hands, would you prefer to see NFS version 3 as being the next protocol? Okay. SMB for Windows? Okay, a few more. An S3 object store on-prem? Oh, wow, okay. So yeah, that's kind of, that's interesting. Okay, cool. For those of you who said S3 object stores, would you expect to access the same objects through multiple protocols? Or does it matter? Who would like to access them both via multiple protocols? So access the same object to S3, maybe through file shares, just one. Okay, 4 or 5. And who doesn't actually care? Most people. Okay, yeah. Okay, cool. So that, I think, is almost close to the end of my time, but I can't keep talking, so it depends on how much time I have left. Anyone know how much time I have? 5 minutes? 5 minutes. Okay, super. Thank you. So let's talk about some of the other integration points that we have. I'll try and go through them quickly enough. So we have a bunch of VMware products already integrated with Kubernetes as well. vRealize operations. Anyone use vRealize operations here? Yeah, quite a few of you, yeah. So there is Kubernetes and container plugins for that. vRealize Network Insight. Yeah. So that's really cool because you're able to see all the communication between the different applications in the different namespaces. That's really excellent integration that they have with VRNI. And also Wavefront. Anybody using Wavefront? So, okay, maybe one person. But Wavefront is really useful for getting application-specific details. And real-time. The thing with VROps is that we're held by the vCenter accumulation of events over time. So I think it's a 5-minute roll-up that goes into VROps. So the thing is, if you had spikes happening, a lot of the time in the roll-up, you lose those. They just get averaged out or whatever. With Wavefront, you actually see everything that's happening in real time. So there are just a couple of screenshots. This is the management pack for container monitoring in VROps. So you can deploy it in PKS as well if you did that. But yeah, it's pretty cool. It's got a lot of good stuff. This is so this is a very simplified view of Network Insight. This is just my old noddy environment, but you can see the relationship even here, what's going on between the different namespaces in Kubernetes. So if you were needing to track that, VRNI is pretty useful for it. This is just the Wavefront part. What's nice about Wavefront is that you're able to do multiple proxies. So if you had a Kubernetes environment that was behind a DMZ, something like that, you can deploy a proxy that can then connect to another proxy, which could be connected to the outside world in order to serve out your Wavefront information. Like I said, the thing with Wavefront is it's providing real-time information and not roll-up information. So pretty cool product. Now, you may have heard that we purchased a company called Heptio. Anyone hear that? So Heptio did an awful lot in the Kubernetes community. They do consultancy and so on, but they also created a whole bunch of open source products, which I'll just touch on here as well. The previous session from our friends at Dell, they were talking about Dell Data Protect and how that's integrating with a product called Velero. Velero is basically a backup product, backup restore. In fact, it's a bit more. It's more of a backup restore and mobility product, so you could move your applications between Kubernetes distributions as well. But it's pretty cool. It's very straightforward to use once you get it set up. Here's me it's Velero backup, creating a backup called Cassandra. And what you can do is you can give it a whole bunch of details about what specifically do you want to back up. Is it a namespace? Is it an application? Whatever. You can list your backups, and then you can just create a restore as well. And as I said, that could be to a completely different Kubernetes cluster. It's really, really neat. So if you are looking for something that you need to back up your Kubernetes applications, Velero is an interesting one. They also have an ingress controller. It's called Contour. And essentially, this is different to a load balancer in Kubernetes insofar as you could use a single IP address for multiple services. Now, typically, when you deploy out a service or an application in Kubernetes, you need a service in order to do networking and reach the outside world and stuff like that. But then it becomes, if you have lots and lots of services, you're using lots and lots of IP addresses and stuff like that. So this is what the ingress controller does here. And try to sort of give a diagram in that if you had a website, let's say it's mydomain.com, and so mydomain.com would have a single IP address, but if you had an ingress controller sitting listening for requests, depending on what the extended URL is, you could redirect it to different services. That's essentially what that ingress is doing. And the final one is Sonabai. I just wanted to mention that because lots and lots of different Kubernetes distributions are using Sonabai just to make sure that their Kubernetes distribution adheres to the Kubernetes specification. So what it is a whole bunch of tests that it runs against your Kubernetes cluster, and at the end of it goes, yes, this is actually a real Kubernetes cluster, and somebody hasn't screwed up an API or something like that somewhere. So it's not just useful for you if you're trying to consider which Kubernetes distribution I want to use, or I'm currently on this Kubernetes distribution and I'm thinking of moving to a different Kubernetes distribution. This is a great way of just testing out to make sure that all of the API calls in all of the Kubernetes distributions that you're using adhere to the specification. Great. And there's a ton of more stuff that I don't have time to talk about. But anyway. So I think that is me. Merci beaucoup. Et au revoir.